This is our fifth question, again of projectile motion. The initial velocity of the projectile has been given as Vx I cap plus Vy j cap. And we have this relation, extra information which has been given to us, that is range of the projectile is 2 times its maximum height. What we need to find out is some relation between Vy and Vx, that is the y component and the x components of the initial velocity. So this question can be easily solved if we remember the formula for range and maximum height, which you should remember. Now range we can write as u square sine 2 theta by g. This is 2 times the maximum height, that is u square sine square theta by 2g. Now when we solve this question, we can cancel this 2, the g gets cancelled, u square gets cancelled, and what we get is that sine 2 theta is equal to sine square theta. Sine 2 theta can be written as 2 sine theta cos theta. Now on solving this gets cancelled and we get tan theta is equal to 2. Now what is tan theta? Now the initial velocity was Vy here and Vx in this direction. The resultant of these two velocities Vy and Vx is the actual initial velocity vector. This is the V initial vector, this is Vy, this is Vx. This is the x component of initial velocity vector, this is the y component of initial velocity vector. And this is actually nothing else but the resultant of these two vectors. And the initial velocity vector is at an angle theta, where theta is the angle of projection. So from this diagram we can clearly see that tan theta is equal to Vy upon Vx, because over here the length of this side of the triangle is equal to the magnitude of Vy vector, that is nothing else but the y component of velocity, and similarly this length is equal to the magnitude of x component of velocity. So we get the relation as tan theta is equal to Vy upon Vx. On substituting here we get Vy is equal to 2 times Vx. This is our required relation for Vy and Vx.